Good morning, dear students, and welcome back to our today's online class. Now, today's class we are going to discuss about electrolytic refining of metals and electrometallurgy, the two other important applications of electrolysis. So, we'll start with electrolytic refining of metals. What is electrolytic refining of metals? It is the process by which metals containing impurities are purified electrolytically to give a pure metal. The process by which metals containing impurities are purified. How? By the passage of electricity to give a pure metal is known as electrolytic refining. Now, metals like zinc, mercury, silver, and copper are refined or purified by this method, by the method of electrolysis. Let us understand the electrolytic refining of metals by taking an example. Electro refining of copper. The industrial method of refining copper by following the electrolysis process has an arrangement something like this. So it has a huge electrolytic vessel, and in that electrolytic vessel the anodes and cathodes are arranged in this way, which are connected to their respective terminals. The negative terminal is the cathode over here, the negative terminal, whereas the positive terminal is the anode. Now let us see what are anodes made up of and what are cathodes made up of. The anodes are made up of slabs of impure copper, and the impurities present in copper are mostly silver and gold. So the impure copper, slabs of impure copper are connected to the positive terminal and are therefore made anode, whereas the negative terminal is connected to a cathode made up of strips of pure copper metal. So they are very thin strips of pure copper and they are made as cathode. So in the electrolytic vessel we keep or we make anodes arranged in this way with some gaps between them, and in each gap we put cathode, which are made up of strips of pure copper metal. So the cathode used over here is strips of pure copper, whereas the anode is impure copper. Now we also need electrolyte. So the electrolyte used in the electro refining of copper is acidified solution of copper sulfate. Acidified solution means solution of copper and acid, and the acid used over here is dilute sulfuric acid, because we need to have the metallic ion similar to the cathode. So over here the metallic ion is Cu plus 4. Let us see the ions present in the electrolyte. The ions present in the electrolytic solutions are cations. We have two types of cations, copper and hydrogen, whereas we have only one anion, and that is sulfate ion. Now if we carefully look at the cations between copper and hydrogen. Copper is in the low position in the electrochemical series compared to hydrogen. So over here, copper readily gets discharged at the cathode instead of hydrogen. And this is why we take a dilute sulfuric acid and a copper sulfate solution. Now let us see the type of reaction at the anode and cathode. Now at the anode, copper metal from the impure mixture loses electron and converts into copper cation. So therefore the copper loses electron, the copper which is there in the anode, impure copper, loses electron and converts into cation and comes into the electrolytic solution. At the same time, the impurities also comes out, but here we are interested in copper cation. So the copper cation from anode comes to the solution. Now this copper cation which is there in the solution now moves towards the cathode, and over there at the cathode it gains 2 electrons and gets deposited on the surface of the cathode, which is pure copper. And the copper which gets deposited on the cathode is also pure. It is 99.9% pure. This is how the refining of copper takes place using electricity or following electrolysis, and it is called electro refining of copper. Now the impurities which also comes out from the anode, they all settle down at the bottom of the electrolytic vessel, and the impurities mainly consist of silver and gold, and the impurities which settle at the bottom of the electrolytic vessel is known as anode mud, because it comes out from the anode and they can be removed from the electrolytic vessel. The net result of the process is, with the passage of time, the anode becomes thinner and thinner due to loss of copper from it, whereas the cathode becomes thicker and thicker due to deposition of pure metallic copper on it, as a result of which we get pure metallic copper. It can be removed and can be melted and transformed into desired shapes. According to our requirement, according to our demand, we can give any shape, size or form to the pure metal. Since the anode becomes thinner and thinner and finally it dissolves, therefore to continue the process of refining copper, we need to replace periodically the anode, which is made up of strips or blocks of impure copper. So at the end, anode becomes like strips of impure copper, whereas cathode becomes like slabs of pure copper. So this is how we purify the copper metal from its impure state. Now we move on to another topic or another important application of electrolysis, that is electrometallurgy. Electrometallurgy is a process of extraction of metal from its ore by the use of electric current, that is by following electrolysis. Metals which are higher in the electrochemical series, such as potassium, calcium, sodium, magnesium and aluminium are mainly extracted by this method, electrolysis method. The list active metals are not extracted by this method. Those metals which are very active, they are only extracted by electrochemical or electrolysis method. Some of the examples are reactive metals are extracted from their molten or fused halides. For example, potassium from fused potassium bromide. Potassium is extracted from fused potassium bromide. Sodium, which is also another active metal, is extracted from fused or molten sodium chloride. In the same way, magnesium is extracted from fused magnesium chloride or molten magnesium chloride. And in the extraction of these active metals, the cathode is made up of iron, while the anode is made up of inert electrode graphite. Now over here we don't extract the active metal from their aqueous solution. The reason behind that is when we use aqueous water with the metallic salts or metallic halides, now they will produce metal cation as well as H plus ion. So there will be two types of ions, cations, metal and H plus. Now if we compare at the electrochemical series, hydrogen ion being lower in the electrochemical series will be the most preferred cation that will be discharged at the cathode. Therefore what happens is, instead of metal cation moving towards cathode and being discharged over there, hydrogen ion will be discharged at the cathode and hydrogen gas will be formed, as a result of which the main purpose of getting pure metal will not be fulfilled. Metal will not be extracted. Instead of that, what will be the product form? Hydrogen gas will be produced at the cathode. Therefore, the active metals are always extracted from their molten or fused halides or salts, but not from aqueous salt solution. In the same way, aluminium can be also extracted by electrolysis. Now, aluminium is extracted from its oxide, and the oxide of aluminium is known as alumina, and formula is Al2O3. Now, alumina is a very, very stable oxide. Therefore, it requires high energy, and therefore we follow the process of electrolysis. Now, the electrolyte used in the extraction of aluminium is a mixture of pure alumina, Al2O3, cryolite, Na3Al(F6), and fluorspar, CaF2. So a right mixture of these three ingredients makes a good electrolyte for the extraction of aluminium by electrolysis. The electrodes used in the extraction of aluminium are: cathode is made up of gas carbon lining of the electrolytic cell. On the walls of the electrolytic cell, a lining of gas carbon is made, and that acts as cathode. Whereas a graphite rod is used as anode in the extraction of aluminium. About the extraction of aluminium we will learn in detail in our next chapter, but in this chapter we are going to know just the basic details of the extraction of aluminium, the electrolyte used, and the electrodes used. In much more detail we are going to study the extraction of aluminium in chapter number 7, metallurgy. this much for today, boys. Based on today's class, you have your assignment number 6, which contains 3 questions. Number 1, electrolysis is used in the purification of copper from impure copper. Name the following in that process. Number A, the anode. Number B, you have to name the cathode. Number C, the electrolyte used. Number D, write the reactions taking place at the 2 electrodes. That means you have to write reaction taking place at the cathode as well as at the anode. Question number 2, why aqueous solutions of salts of active metals are not used in the extraction of metals by electrolysis, which I have told you in this video. Number 3, name the electrolyte used in the extraction of aluminium. So these are the 3 questions which will be your assignment for today's class. We'll meet or we'll discuss about metallurgy in our next chapter. Till then, stay safe and do all things well.